Hello guys! In this video we are going to continue with integrals, basic methods, immediate integrals all the time. But in each video we are going to see a different formula. In this case we are going to try to solve logarithm integrals. We are going to see how to apply the formula of logarithm integrals, and we will need some notions of integration and calculus for sure, and simplifying expressions. Why is this video after the chain rule? Please watch the chain rule videos before this one. Why? Because if you remember, the chain rule couldn't be applied when the exponent was -1. This is because this integral is of this type, is a logarithm integral, or could be a logarithm integral. Okay, we will see what happens. What is the formula of logarithm integrals? This is also, if it is not the most, because the most is the power rule formula, the most important, this is the second most important formula in integrals. Okay, what do you see in here? What is the pattern we are going to follow? You are going to see a fraction, a quotient, between two functions. Anytime you see something like this in integral, one of the first thoughts you need to have is, okay, wait a moment. I have the derivative of the denominator on the numerator. If this is true, then the integral is trivial. It's the logarithm, natural logarithm of the function in absolute value. The absolute value is applied because the logarithm is only, the domain of the logarithm is only for positive values. If you don't put the absolute value, this could mean that the function is negative and you have problems. So we normally add the absolute value to make sure that the function is positive. Okay, so let me recall the formula. I see a fraction, I see a quotient in an exercise. The first thing you need to do is to make sure, or ask yourself, if the derivative of the denominator is in the numerator. If this happens, no problem. You can apply this formula. It's the natural logarithm of the denominator in absolute value. This formula can be simplified if you take the function as x only. The integral of 1 over x, the derivative of x is 1, as you see here, is on the numerator. The derivative of x is 1. Then this is the natural logarithm of the absolute value of x plus c. Sorry, I made a mistake here. It's plus the constant. Okay? So, piece of cake. I think it's not difficult in this case. Come on, let's see some examples. Obvious examples. Someone asked us to solve 2x divided by x squared plus 1. Again, first thing I notice, a fraction, a quotient, perfect, a quotient of two polynomials. Let me see. Question, the derivative of the denominator is on the numerator, and the answer, for sure, all of you are seeing this, the derivative is 2x, the derivative of the denominator is 2x. Oh, it's on the numerator. So the formula tells me that this is the natural logarithm of the denominator in absolute value. Sorry, in this case, the absolute value is not needed because x squared plus 1 is always positive. But I just kept the absolute value just for you to get used to add this absolute value at the end. Okay, so piece of cake. The only thing you need to check is if the derivative of the denominator is in the numerator. Another example. Okay, let's see. What do we have here? The denominator is x cubed minus 2 times x. And the numerator is the derivative of the denominator. Let's see, the derivative of x cubed is 3x squared, the derivative of 2x is -2. Perfect. So I got a quotient in which the derivative of the denominator is in the numerator. Perfect. What is the solution? The natural logarithm of the denominator. Nothing else. As you can see, we are not doing very hard things. The only thing I'm doing is calculating derivatives, even though that I'm integrating, okay? I'm just checking if the derivative is around. Come on, another example. Cosine over sine, piece of cake again. A quotient. First thing you need to think is, okay, is the derivative of the denominator in the numerator? The answer is yes again. The derivative of sine is cosine, and it's in the numerator. So what is the solution? I give you 5 seconds to answer. Natural logarithm of the sine of x in absolute value. Okay, the natural logarithm of the denominator. Another example, look at this one. 1 over x divided by logarithm of x. Again, I see a quotient. I don't care if it is difficult or not, or it seems difficult. In this case, it's trivial. The derivative of natural logarithm, as you know, it's 1 over x. So I got the derivative of the natural logarithm on the numerator. What is going to be that? the natural logarithm of the natural logarithm of x. Yeah, seems confusing, but what the formula told you, it's the natural logarithm of the denominator. It doesn't matter if the denominator is another logarithm. Yeah, I know it seems confusing, but it's applying the formula again, exactly. Okay, so one more. Ex plus 1 on the denominator, ex on the numerator. Be careful, because my students normally try to simplify this, separating into fractions. Be careful, that's not correct. Okay, so the first thing you need to do when you see a fraction, a quotient like this one is the derivative of the denominator on the numerator? Yes, again, look at this. The derivative of e to the x is e to the x. The derivative of 1 is 0. Okay, so perfect. I got the derivative on the numerator. So what is the integral of that? Is the natural logarithm of the absolute value of the denominator, whatever the denominator is. Okay? Another example. In this case, we are missing something, as you are going to see. We have a denominator x cubed plus 1. On the numerator, I have x squared. Okay? The derivative of the denominator is in the numerator. The answer is no. Almost, but no. The derivative is 3x squared. I don't have the 3 on the numerator. One constant is missing. It doesn't matter. I can solve this. How are we going to do that? I'm going to put the 3 that I'm missing, but I'm going to compensate this 3 multiplying the integral by 1/3. Okay, constant can be put inside and outside, so it doesn't matter where you put the constant. But get used to add the constant you need inside the integral and the one you add to compensate the one you have just put inside outside, just to make sure that you kept the one outside at the solution. So now what do we have? A function, and on top I got the derivative of the denominator. I can apply the formula to this integral. So what are we going to have? 1/3 that remains the same times the logarithm of x cubed plus 1 plus c. Okay, it's piece of cake, the logarithm of the denominator. Another exercise, sine over cosine. It's almost the one we just saw before, but in a different order. The question is the derivative of cosine on the numerator? And the answer is almost. The derivative of cosine is negative sine. So what I'm going to do, I'm going to add a negative on the numerator, and I'm going to add one negative outside of the integral. These two negatives cancel each other, so it's like I'm doing nothing. But now I have the derivative of the denominator on the numerator. Then what is that? Negative natural logarithm of the absolute value of the denominator. Okay? And that's all. What have we seen in this video? We just reviewed the logarithm integrals, and we also practiced some mathematical properties during the process. I hope you find this helpful, and thank you for your attention.